Continuing from our last video, this is now video 3 in our limit series, and we're just going to finish off with some limits problems looking at sine. I've chosen sine instead of cos, but you could also look at some problems with cos. And we're looking at, or we'll get to why we're looking at these as they're a special kind of function. So first we'll take a look at 3a. And we're taking the limit of sine as it approaches 0. So if we were now to consider, and we were to put in a value of sine of 0, we can see by looking at our sine graph here that as x approaches 0, sine also approaches 0. And as this is converging to a value, we don't actually have to consider what direction we're approaching 0. So we can say then that this value here for our limit is 0. So as x goes to 0, sine x goes to 0. It's very nice and straightforward, the first one. Now for b, this is why I picked sine as opposed to other functions. So b, we're taking the limit of x as it goes to infinity. So we're taking our x value and we're just going across and we're trying to find what our y value becomes as we get to infinity. Now what you should notice is it doesn't matter how much we go in the x direction to infinity, or for that matter this would also work for minus infinity. We can see that the y value of sine still alternates between 1 and minus 1 continually. It never changes. So it doesn't have a limit. So as x goes to infinity, sine is always going to still be between 1 and minus 1. So sine, for that part, doesn't have a limit. So taking that into account, we'll come to our next question. So now we're still taking our limit for sine, and we're still taking it to infinity. But this time we're dividing our function of sine by x. So we have the limit here of sine x over x. Now, what this tells us is we have a value at the top of sine x, where sine x is less than or equal to 1 and more than or equal to minus 1. And this value is being divided down by infinity. So we know we have a value between minus 1 and 1. And we know anything divided by infinity now approaches 0. And again, it's not diverging away, it's approaching a value. So we can now say that it doesn't really matter where the value of sine lies. The fact that now it's divided by the x means that as x goes to infinity, our function of x goes to 0, as sine only alternates. And I'm actually going to, we'll draw this on. We're going towards infinity from 0, and our sine would start to decay. And if we take a very, very big scale of this, a very zoomed out scale I should say, take it here, what we'd actually start to see is sine would just decay down to 0. Ignore this one where I messed up a little bit there. Yeah, it will decay down to 0. Its amplitude would lessen with each successive oscillation, dampening it down to 0. So, then we finally come to D. So for this one, we've got the limit, the same function, sine x over x, and our limit is going to 0. Now this one's a little bit more complicated. So what we've got to consider is here, our limit as we're approaching 0, we've constantly got a value which is alternating in sign. So we can't really treat it as we'd normally think. So the best way to do this is to separate it. So I'm not going to write out limit of x to 0 every time, but know that applies to everything I'd write, because it will just waste both of our time doing that. So we separate this out now into 1 over x by sine x. Now, if we take the limit of our sine x, we know that our sine x value from earlier, the limit of sine x going to 0 from our last video, gives us 0. And 1 over x, the limit of anything over x, is infinity. So now we have infinity by 0. And this actually here is something very interesting, which is why I decided to choose this one. If we have anything where we're getting a limit of infinity by 0, effectively we get 1. And I'll show you this works, because now we can also consider that zero is also given as 1 over infinity. So then if we multiply these two values together, what we actually have is infinity by infinity to the minus 1, which is infinity over infinity, which equals 1. So if you ever get that, where you have two, you manage to separate it out yourself, and you've got two limits, and you've found for yourself that you have infinity by 0, you know that's going to 1. So for this, as our function of x, as x goes to 0, our function of x goes to 1. And that's all for my examples on limits for infinity, minus infinity, and 0.